So today I want to talk about probability of compound events, and this is taking what we did yesterday with theoretical and experimental probability and expanding it. So instead of just spinning the spinner once, we're going to spin the spinner 2 times, or we're going to roll the dice and then spin the spinner. That's what compound events are. So the formal definition: 2 or more events linked by the word and or the word or. The probability is combined. What are my chances of this happening and this happening? Or what's the probability that this will happen or this will happen? We're going to do lots of examples tomorrow in class. So the first one you have is mutually exclusive, where there are no outcomes in common. So one example could be, what's the probability that I'm going to spin a green or an orange? All right. So you take the probability of green, it's 1 out of 5, and you take the probability of orange, 1 out of 5, and you simply add them. I've got 2 chances out of 5 of getting a green or an orange. That is mutually exclusive events. Now, overlapping events is exactly what it says. Something overlaps. It has at least one outcome in common. All right, so for example, the dice. What's the probability that I'm going to roll a 2 or a multiple of 2? Now, a multiple of 2 is 2, and I already said 2, so they overlap. That's something they have in common. So you would add all of your chances, but you would subtract what they have in common. Anything that overlaps, anything that is counted twice, you would subtract that. Again, we are going to do examples of this tomorrow. But you do not count it when it happens 2, 3, 4 times, whatever. If it happens more than once, you subtract it. Now, the probability of 2 independent events, they have no influence on each other whatsoever. They're separate. So as you can see my examples there, what's the probability of me spinning blue and getting the 10 of clubs? All right. They have no influence. What I spin doesn't make a difference on what I pick with the cards. For this, you're going to multiply. All right. You would multiply the probabilities to get the total probability. And selecting with replacement. So the probability is separate. It's individual. The probability is not combined. So what this is saying is, what's the probability of me picking a blue marble, putting it back in the jar, and then picking a red marble? All right. With replacement means I put that blue marble back into the bucket. I put it back into the bin. Keywords to look for are and then. So again, with the probability, you're going to take it and you're going to multiply it. Most of the probability is multiplied, some are added. Selecting without replacement, the probability is dependent. One event influences the other. Right? You are taking something from the original sample, so the denominator is not going to be the same. Keywords, again, are and then. So, for example, what's the probability of me picking a yellow marble and then another yellow marble? All right. Because I took one yellow marble out and I'm not putting it back, the total marbles in that jar has changed. So when I multiply the 2, the denominators are going to be different. The denominator in the second number is going to be 1 less because I picked 1 marble. We are going to look at a lot of this stuff tomorrow. I think you guys will like it. All right, see you then.